So far, we have discussed about all the supervised machine learning techniques, but I think now it's a good time to start the other area, what we call unsupervised learning. So this is, we are kicking in the discussion, but some of the items we will be linking to what we have learned so far. And first, we'll try to learn what is the distinction, what is the difference between these two ML techniques. Okay. So let's do a recap, because we learned about classification, we learned about regression. So these are actually some well-known examples of supervised learning. So to understand what we mean by supervised learning, you can start by looking at the data format that we used. If you recall, we learned about regression and classification tasks. And in terms of data, we had features and also labels. For example, for the classification tasks, we were given certain features, and one of the problems that we can link to the classification problem is that whether these features actually referring to a dog or a cat or a rabbit. So this is a kind of animal classification data. And we have seen breast cancer classification, then the digit classification examples in our previous lecture. We also learned about regression tasks. For regression, we have the features, and the difference with the classification task is the target variable here is a real data variable. So for the classification, you have a closed set of class labels, and for regression, you have some real value as your target variable. And we have seen a few examples in our regression learning part. For example, the diabetes score prediction. So if we look from the data perspective, we can clearly identify that for unsupervised learning, you are given the features, but you are not given the Y's or the target variables. So we are given only the features. So whatever you have to learn is only from the features. So that is the one prime distinction between supervised and unsupervised learning, if you look at from the data perspective. So here I have a summary of what we have just discussed. So for supervised learning, classification and regression, you have both features and labels. And for unsupervised learning, you will mostly learn with your features. No labels are usually provided. You might have some small number of labels, but the main distinction is whether you have labels or not. Okay. And one popular example of unsupervised learning is clustering. So for the next few days, we will be learning about different types of clustering algorithms. You might have heard about k-means, then hierarchical clustering, and then Gaussian mixture model, and another distribution-based model that we'll be learning, what we call DB-scan. And for clustering, another important topic we will cover is that how do you identify the number of clusters within the data. So let's start with clustering. As I mentioned, that for unsupervised learning, you will only have the features, that is X, as your input. And the idea of clustering is you group these features based on some criteria that we will be learning. So you group those data instances, and it is you who will come up with some labels. So the labels are actually the cluster indexes. For example, for the images, we have here a few apples, and in terms of feature, we can think that, okay, these are red apples, these are green apples. Also, we can think that, okay, these are small apples, these are bigger apples, and the middle ones are kind of medium-sized apples. So you can use their size, their color, or maybe both to actually do the clustering. So let's try this data to understand a little bit more. So for example, if I take the color of the apples, then it is likely that we'll have two clusters. So these are the red apples and these are the green apples. Okay. So you see that if we concentrate on the color, then we'll have this kind of cluster, and then you said that, okay, this is a cluster index 1 or cluster number 1 and this is cluster number 2. But here you have full flexibility that, okay, I have two clusters, but I can assign any number to these two clusters as their indexes. Okay, let's say that we have two clusters, 1 and 2, and now we have a new apple. And if you recall, we used color as our grouping of or clustering of my data. Then you can say that, okay, my test instance is of color red. So let's look at that again. So it is a red apple, so I labeled that new instance to cluster 1 because that's how I actually grouped and indexed my clusters. Okay, let's see another example. So here we are using the size as the clustering feature, and you can see that now we have 3 clusters. So previously using color we had 2 clusters, and now when we are using size as the clustering parameter or feature, then it turned out to be that the data has 3 clusters. So again, here the number of clusters are actually not predefined. It is the features that are actually driving to create those clusters. And here you have 3 clusters, and it is upon you who will do the index assignments. So here I have assigned cluster number 3 to the smallest apples, then 2, and then 1. Okay, and now if you have a test case, the same apple that we labeled in the case of clustering by color, and here we are using the size as our clustering feature. So it turned out to be that this new apple is most likely going to be on cluster 3. Okay, so you see, based on did set up our experiment, same data and then the same test level are getting different cluster indexes and a different number of clusters. Your clustering results are different number of clusters, and also the test data being labeled as different cluster indexes as output. Okay, so in summary, clustering is unsupervised learning as we started learning this part. And the idea of clustering is grouping data points based on some criteria and some features, because at the end of the day, we only have these features as our input. We use these features to actually create a grouping of data points. And we have seen that for this particular case, if we use color as our driving feature, then we had 2 clusters. And same for the same data sample, if we use size as our driving feature, then it turned out to be we have 3 clusters, and there is no predefined cluster index level. So it doesn't matter that whether you cluster level it as 1 and 3, this one, 2 or 1, it doesn't matter, because it is you who will index those clusters or label those clusters. And if I go back to my first slide, we are saying that the supervised learning, like for classification and regression, are learning with both features and levels. And in case of unsupervised learning, we are learning something only from the feature space, no predefined levels provided